Morning and welcome to Calculus in the AM. Recording. Coming to you live on recording. And we're just going to give you a second to do the first derivative. I'm pausing. You'll tell me what you got. Look away, pause the video. So hopefully this is your first derivative. I'm starting up the video again. We want to find critical numbers, so we set it equal to 0 and factor it. See there's a common factor of the number 5. I'll pull that out. And x to the, go with the lowest exponent, 1/3. Then I think, well, 5 divided by 5, it's 1. X to the 2/3 divided by 1/3. So you subtract, right? 2/3 minus 1/3. X to the 1/3. Okay. Subtracting 2 and x to the 1/3 in exact match. Okay. From this, I should be able to see my two possible, my two zeros there, the critical numbers. X equals 0. Can you guys just take a look? If you set x to the 1/3 minus 2 equal to 0, your critical number, what? Third is a cube root, right? So it must be? Well, let's just solve this then. Give myself some space here. So for this one here, this means set the cube root of 2, or cube root minus 2 equal to 0. When does the cube root equal positive 2? How do you undo a cube root? I hope you know. Yeah, you do Castro's move. Cubing, right? Yeah. Do some cubing. X equals 8. That's your other critical number.
Oh, I see.
Because I know what you're thinking, 2 minus 2, but you have to say, well, cube root of what gives me 2? If you want to do it in just one thinking step. So, if you want to show that work, go ahead. If you knew it was 8, great. 8 is great. Now, I'm going to just erase my arithmetic on the side that we went over. And that's sort of like my A part, right? Then what do I do next? I do a little sign analysis so I can answer the rest of the questions easier. So I've got 0, I've got 8, and I don't need to put any other numbers on here. My factors are 5, x to the 1/3. And there's no restrictions on cube roots. X to the 1/3 minus 2. I say, well, 5 times the cube root of x gives me a 0. Well, you guys do it for a second here. I'll pause. So our sign analysis, we ripped it through. Region of increase, followed by decrease, followed by increase. I'm going to do a quick sketch so I can identify my maxes and mins. Increase, decrease, increase. That's straight lines, no regard to curviness, concavity. But we could see where our maxes and mins, relative maxes and mins are, and where our regions of increase and decrease are. So, let's get to that. Let's do the increasing. It's increasing on. On the intervals, negative infinity, go from left to right to 0, and, or in union with 8, and up. How do I know that? It's because the first derivative is greater than 0. It's positive. It could be equal to 0 a small, countable, finite number of times as well, but that's not the case. And it's decreasing on the interval from 0 to 8. Since the derivative, the first derivative, is negative. Furthermore, maximums and minimums. We can quickly see that 0 is a relative. Maximum, relative max. At the point, because we want a point, it occurs at 0. Take a look at the original equation. You put 0 in there, it's 0 minus 0. So at the point 0, 0, right? Since the derivative switches signs. From increasing to decreasing, positive to negative. That's justifying my answer. Relative minimum. At 8, comma. I have to do a little bit of arithmetic for this one. I can't just look at it and see that it's 0. Might even be wise for me to jot this down.
That's not the original.
Oh, yeah, I haven't slid back up. I just noticed, yowzers. I was lucky with the, I used that for my 0, but it is still 0. You guys gotta catch me on these things. I just looked at the top of the page, didn't even look at it. Thank you.
No problem.
Hope there's no confusion. You're watching the video now. Okay, anyway. 8's cube root. Oh my goodness. Yeah, I'm gonna do some job work down here. Because you do that 3 times, you guys got calculators too. And sometimes these things aren't easy to enter in the calculator too. So 3 times the cube root of 8 and then to the power of 5, right? So I'm doing my math. 15 halves. Cube root 8, then to the power of 4. Yeah. I'm this close to the board, I really have a hard time seeing. Anyway, enough about me and my medical maladies. Cube root of 8, as we know, is 2. 2 to the 5 is 32, isn't it? Yep.
Yeah.
32 times 3 is 96. You got a calculator, but I mean. And some calculators screw up when you do like 5/3 as a power. So that's why it depends what brand of calculator you have. Subtracting 15 halves times the cube root of 8 is 2. 2 to the power of 4, 16, right? Now, I'm not doing 16 times 15. I'm cutting her down. I'm doing 8 times 15. 8 times 15 is 80 plus half of that, 120. 96 minus 120 is going to be negative 24. So that means, to finish my relative min statement here, 8 comma negative 24. Since f prime of x switches up from, I'm going to squeeze it in here, I like using the words, but negative to positive. Okay. So I'm squeezing it in there because I left myself in a little, painted myself in the corner. Okay. That's about what we can get from a first derivative. By the way, this time I wanted to do this function because, you know, the example we did the other day, you could have graphed probably using first principles from no calculus at all. It's easier with calculus. This one here, I don't think you have a clue what this looks like, right? The other one you had a clue. Because it was a straight up easy or polynomial. Okay, second derivative coming up. So I look at my first derivative and I look, it's easier to not use the factor form. I'm doing the derivative of that part of the expression. So when I look at that, I say, well, 2/3 times 5, and so on. So I'll give you guys a second to do that. We'll compare notes and factor it right away. Set it equal to 0, factor it, and then we'll compare. I'll stop the video for a minute. Do your work. Okay, what are we going to take? Okay, so hopefully you got a second derivative. Common factor. I'm going to set this equal to 0 because I'm looking for possible, we don't call them critical points, these are possible inflection points as long as the second derivative changes signs. 10/3 is an obvious number. x to the smallest degree, 2/3. Hold up. So, negative 1/3 minus negative is actually adding 2/3. So you get x to the 1/3. Subtracting 1. This one's a little quicker to find your possible inflection points. I've got x equals 0 and 1. The cube root of 1 minus 1. We'll see if these are inflection points by doing some sign analysis. So we know the trick. Zeros and ones. I've got 10/3 x to the negative 2/3 x to the 1/3, subtracting 1. Now let's be careful when we do this. With this setup, you actually don't, the second derivative doesn't, you can't evaluate it at 0 because it's a reciprocal, right? But it's still a possible point because it's in the domain of the original function. That's what counts. So I'm going to put 0 like this, but you can't actually get that value, right? Like, if you follow what I'm saying there. But it is in the domain of the original function. I'm just maybe I won't do it that way then. I'll just put it with the 0. It's proper in the original function. Just keep it in mind, though. It's inflection points and critical points are points where you either get 0 or else where the derivative, or in this case second derivative, doesn't exist. However, they are in the original. So anyways, anything smaller than that will be negatives, positives. This is the easy part. Now let's just think this through. How does this one work? Well, anything higher, the cube root of 8 minus 1. Okay, well that's going to be positive, higher than 1. Anything smaller. So if I put in 0, for example, there, you're going to get negatives. Put in negative 8, you're going to get negatives, right? I think this is all negative on the left. Okay, good. So we got a positive, concave up zone, negative, concave down zone, positive. So, although this won't connect like this, I'm thinking, yeah. I'm just doing this literal, but don't think of these as joined necessarily. It's not going to necessarily look like a cosine or sine function. It's not necessarily sinusoidal in nature. That's where we got to put everything together. Now, from this, we can get our inflection points. No inflection points. Just a second here. What did I do? What's wrong? Tell me. Or did I do something that's wrong? Nobody sees my error? I saw it. I was strictly thinking negative 1/3. But what does that 2 on the top mean?
Like to the negative 2.
Negative 2/3. All the negative means it's on the bottom. But then you square your answer. That's positive. Good gravy, Shindalka. Not happy. That's what you're thinking. Hey, let's go with this again here. A negative. Negative. Okay. My mistake. Then we're ready to cook with gas. So 0 is not an inflection point. 1 is the only inflection point. If you put 1 into the original expression, let me see, I have it worked out. I got negative 9/2 last time. So the inflection point, here we go. From the original equation. What else? The intercept. We know that 0, 0 is an intercept, eh? Now the other intercept is a doozy. because we want to know where it crosses the x-axis. So, intersects. Yeah, we saw 0, 0 already. And is there another one? Well, we got to take the original expression, yowzers, set it equal to 0. That means we've got to do some factoring, some moving on this one. I'm going to pause this and get set up. So now we're in the business of finding the other intercept, and it ain't going to be nice. So I take out, let's take out the half as well. There's a factor of 3 between 15 and 3. And let's take out the half, just because fractions suck for most people. So 3 halves, x to the lowest, x to the 4/3. See where this ends up. 3 divided by 3 halves, that's 2. 3 divided by 1 half, that's 2. X to the 5/3 minus 4/3, that's 1/3. Subtracting 15 halves divided by 3 halves. It's really 15 divided by 3, it's 5. The x is an exact match. I set both of those equal to 0. Now we already know the first one. 0 is 0, and 0 comma 0, we've identified that above. We're going for this baby here then. So, 2x to the 1/3 minus 5 equals 0. This is going back to like grade 10 when you started factoring to solve quadratics. You'd actually literally set those factors equal to 0 and solve them instead of doing it in your head. This is a little more complicated than you'd want to do in your head. Maybe you could. So then I think, well, that's 2x to the 1/3, which equals positive 5. Then I can divide out the 2. So x to the 1/3 equals 5 halves, right? By slipping the 5 over, add it, make your zeros and then your ones. Then you divide by 2. Then, how do you undo a cube root? You cube it. 125 over 4. Well, that's great. 125, just wait here, guys. I didn't cube it, did I? I squared it. Yeah, just thinking here, what am I doing? It's the second mistake I made today. That's not bad. Only 2 mistakes. I caught it. Well, I think I've made 3 mistakes I've caught. Anyways, what is 125 over 8 as an approximate number, just so you know where to put it on a number line?
50.6-ish.
Yeah, did you do it in a calculator?
Yeah.
Oh, yeah, you pretended to estimate it. I could tell.
Yeah.
That's how you 15.62 something. It's in the quarters. It is 65. But I'm saying one thing and writing the other. I can't talk at the same time. So I'm doing that so I know where to put it on the number line. But my exact answer is intercepts at 8. What am I saying? 125 over 8. 0. Sorry, I was thinking about something else. The y value is 0. Where do we graph? Where do we begin? Well, this has turned into a mega long page, hasn't it? I'm going to just scoot some stuff over. Okay. I'm going to plot the 2 intercepts. 0, comma 0. That one I don't need to mark. It's right on the y-axis, x-axis. Then my one that's 15 and 6 decimal 6, so it's just under 16. I'm going to put that there. So 125 over 8. If you like to, you can just put a 15 here. Just know where it is here. 15. A little higher. Now, I don't need to mark a bunch of things. We're not drawing it to scale. But my 2 and 4 is where the action is, right? And 1, wasn't it? I scale up. Yeah. Critical numbers, 0 and 8. Oh, 8 was the action too. So about halfway in between here, you know. Plot my minimum, 8 and negative 24. put the ordered pair here, right? Negative 24. It's not drawn to scale, but I'm showing features of the grid. Now, the zero's already plotted there. Then what? I'm looking through my list here. Concave down and up, 1 and 9 halves. So, like I said, I'm not drawing it to scale exactly, but I'm making it closer to the 0 here. 9 halves, negative 4 and a half, right? So that's a little ways down. So I'm going to call this, I'll put it up there. 1 and negative 9 halves, 4 and a half. If you wish, it's a precise decimal. So there's my max at 0, 0. I think you can see that. So then what? I think you can tell the story here kind of too, but let's just double check with our sign analysis, the first derivative. Increase to 0, decrease to 8, increase. Okay, so I'm thinking increase, decrease, increase. Now this is not drawn to scale, so yours might be a little different. Maybe you would correctly have the 1 closer over, for example. Maybe not. Whatever. I'm not worried too much. As long as it looks like it's closer to 0 than it is to 8, I'm good with that, right? So then, we say concavity changes at 1, right? We know it increases to 0, so I'm thinking, let me double check the concavity here. Concave down, yep, all the way up to 1 and then concave up. So it's going to be like this. That's going to be like this. Okay, that's a really rough sketch. That's disappearing. Be more careful, which it's hard to do, but that's the story, guys. Okay. So when I am marking, how am I looking? Now you guys can be a little more careful because pencil sketches are better. I am looking. Have you clearly identified the ordered pairs of your intercepts? I am looking. Your maximum and minimums, are they clearly identified, like with ordered pairs? I guess I didn't put 0, 0 here, but that one's the only obvious point you can get away without putting if it's. Did your inflection point get labeled? And not only that, does it look like it changes from concave down to concave up? It does in my drawing. So make sure yours is. Because some people will go through the inflection point and not change until later. Don't make it ambiguous. Make it look like it. Okay? And make it a smooth curve. Yeah.
I still don't understand how you factor 3x with 5 minutes.
Sure, we'll go over the factor.
Yeah.